We are live.
Okay. Hello everyone. Welcome to the GATE Academy. So in the previous session we have already covered up to the screw check. I hope up to then there is no doubt. So if you have any doubt regarding previous session which we have already discussed, then you can tell here. Otherwise we may proceed. Please respond.
This is audible.
Okay, fine. So right now we can start. So up to here we have already discussed that what is the overhauling screw and what is the self-locking screw. Fine. So what is the overhauling and what is the self-locking screw? So when I is saying that, could you please drive the formula for screw jack? So actually I have already asked at that time that is it important to drive? So most of you have answered that we can proceed with the expression only. That's why I mentioned here. But right now it is too late that again we come back to drive the expression. So please understand this. I don't think that there is any complication in this relation. The formula and the derivation part is very easy. Okay, Anwar, I am waiting for the remaining one. So once all students will be there, I will start the session. Fine. Okay, so up to this, whatever we have covered in screw jack, is there any doubt? Then I can resolve up to when more number of people are joining the session. Fine. So please share this session with your friend also and subscribe our channel so that for upcoming videos you will get the instant notification. Fine. Okay, so there are already number of pupils have joined. Fine. So right now I am going to right now I am going to drive the efficiency of a screw jack. Fine. So these two formula I have, you have memorized, because the expression is very simple. It is d over 2l multiplied by w tan phi minus alpha, and in case of raising the load, the sign will be positive. And here we have already seen that if the angle of friction will be less than the helix angle, in that condition the screw will be overhauling. That means when we will remove the load, when we will remove the effort, in that condition what will be had, due to the weight of that load, screw will automatically lock down. Screw will automatically starts to lower the load. Fine. So that condition should be avoided. That's why we keep the friction angle greater than the helix angle. And this condition is known as the self-locking screw. So this is the first condition with which we can conclude that given screw is self-locking or not. Otherwise, we may also conclude the type of screw on the basis of its efficiency, that we are going to cover in this session only. Fine. So right now we are going to start efficiency of a screw jack. So here we will define the efficiency of screw jack with the help of two formulas. So please be attentive for this part, because from this concept already, I think from this concept number of times question has been asked in other examination, for example engineering services and the SSC JEE examination. So on the same pattern the question can be asked. So we will discuss about those questions. Fine. So see here, what is the efficiency of a screw jack? So as you know, the efficiency of screw jack is the ratio of ideal effort to the actual effort. So it is the ratio of ideal effort to the actual effort. Now what is the actual effort? Actual effort, we have already derived that relation. what is the actual effort? So we have already derived that for raising the load, it is d over 12 w sine w10 phi plus minus alpha. Here I am writing plus minus, plus for raising the load, and for low the load. This is the effort that we are applying to raise the load. But what about the ideal effort? So in ideal condition, we assumes that there is no friction, in the absence of friction. So what will be the effort required in the, so that means if friction is not there, that means this component will not be there. That means we can say that in the condition efficiency of this condition, if the friction will not be there, that means phi will not be there. So correspond to that, we can see that P will be equal to P is equal to D divided by 2L W10 alpha. This is the ideal effort. So this is the ideal effort. And what about the actual? This is the actual effort. So if we want to calculate the efficiency, then how we can calculate? Just take the ratio of both. So efficiency in case of raising, it will be equal to D divided by 2L, and this is when phi is equal to 0. Fine. So D divided by 2L, this is 10 alpha divided by D divided by 2L W 10 phi plus alpha. This is 10 phi plus alpha. That means here, from here these two terms will cancel out. So what efficiency you will get? So you will get efficiency for raising the load. It is nothing but 10 alpha divided by 10 phi plus. Is it okay? Any doubt? So keep this formula in your mind, because from this concept the question can be asked. In the same way, this is for raising. And what about the lowering? Because the formula is same, that means what you will get? You will get efficiency will be equal to 10 alpha divided by 10 phi minus alpha. Now, what is important here? What is important here? So see here, as you can see in the relation of efficiency, there is neither load nor the effort. That means the efficiency of a screw jack is independent of P and W. So efficiency of a screw jack is independent from effort and load raised. So whatever the load is raising and whatever the effort is applying, that efficiency of that screw jack is from both the term. Fine. It depends only on helix angle and the angle of friction. So this is all about the efficiency of a screw jack. Fine. Now, if you want to explain the efficiency in another term, then how you can explain? So in before explaining the efficiency in other terms with the other formulas, here one thing we need to know, that how we can judge that a given screw is a self-locking screw or overhauling screw. So now see here, as you know that what is the condition for overhauling? So the condition for overhauling is that the coefficient of friction is less than alpha. Fine. And what is the condition for self-locking? That phi should be greater than alpha. So we are considering that phi is nearly equal to alpha, because that will be the limiting condition. If phi value is nearly equal to alpha, so that will be limiting condition. So what will happen? So when you will put alpha is equal to phi, that means what you will get, and we will put this alpha is equal to phi, in which case lowering load, because when the load is being lowered, in that condition we will see the phenomena of overhauling and the self-locking. So how we can see the efficiency of screw? So right now we are considering the condition of self-locking. So we are considering the limiting condition by putting phi is equal to alpha. So what is the limiting condition? Now we are putting the value in this relation. So from here you will get this is tan phi and divided by this is this is tan phi plus alpha. Sorry, one more term. Efficiency, this is equal to tan phi plus alpha. This is all okay, and I think the relation is it is tan phi plus alpha. Sorry, this is phi minus alpha. So this will be equal to tan alpha divided by tan phi minus alpha. So we are putting this expression in this value. So this will be equal to tan alpha by tan phi minus alpha. So this will be equal to tan phi minus phi. I am getting confused. Is there something missing? Let me check this. This is tan alpha, tan phi, phi minus phi. This is tan alpha phi by minus alpha. So phi is greater than alpha. We are putting tan alpha. Actually, this term should be 2 tan phi. Tan phi. This is tan phi minus. Actually, so give me some time. I'll check this, and after that I'll tell you. So before that, I will explain. Before that, I will explain what is the efficiency in other terms. Give me one more minute, so that I will check this relation where we will facing problem. Fine. So the efficiency of Screwjack in other terms. First, we will see this efficiency. It is not working. Yeah, efficiency of Screwjack. We can define efficiency of Screwjack in other terms with the help of mechanical advantage, because the efficiency of any machine is the ratio of efficiency is equal to mechanical advantage divided by the velocity ratio. So the efficiency of Screwjack can also be defined like this. Now, what is the mechanical advantage? Can anybody tell what is the mechanical advantage? What is the mechanical advantage? Anybody? What is the mechanical advantage? So mechanical advantage is nothing but it is the ratio of load lifted to the effort applied. And what is the load lifted? As you can see, in case of load lifted is what? Load lifted is nothing but W. And what is the effort applied? So effort applied is equal to P. That means if in the question it was asked what is the mechanical advantage, then we can calculate mechanical advantage is equal to P. And how the P can be calculated? For this we have already seen one expression. P is equal to what? P is equal to divided by 12. D divided by 12. This is W tan phi minus alpha. For lowering the load and for raising the load, it will be plus. So I am writing here tan phi plus minus alpha. Fine. So in this way we can calculate the mechanical advantage. Now come to the velocity ratio. How you can calculate the velocity ratio of a Screwjack? Now this is more important. Why? The same concept I am going to use in case of differential Screwjack. So please see here what is the velocity ratio. So it is the distance traveled by the effort, distance traveled by effort divided by distance traveled by the load. So what is the velocity ratio? It is nothing but it is the distance traveled by one effort divided by the distance traveled by one load. And in this way we can calculate the velocity ratio. Now we will check. For example, this is the effort, and we are applying our effort at a distance of L at the end of lever. So can anybody tell me what will be the distance traveled by the effort in one revolution? In one revolution, what is the distance? Because it is in horizontal plane, this circle I am drawing in horizontal plane. Fine. So can anybody tell in one revolution what is the distance traveled by the effort? What is the distance traveled by the effort? Anyone? Distance traveled by the effort. What will be the distance traveled by the effort? So as you know, because this effort will in one revolution, what distance it will cover? It will cover a distance equal to the periphery of the circle. What is the periphery of the circle? That is nothing but d pi d in pi d. So, or we can say that 2 pi r. Fine. Now, what is the r here? So, I is nothing but r is equal to what? R is equal to L. So if you want to write that what is the distance traveled by the effort, so that will be nothing but 2 pi. This is the distance traveled by the effort. Now, if you're talking about distance traveled by one load, so what is the distance traveled by the load in one revolution? As you know, because the load is traveling the distance in this direction, that means in one revolution it will cover a distance equal to the one turn. So can anybody tell me that what is the axial distance traveled by the load in one revolution? What is the distance traveled by the load in one revolution if pitch of the screw is P? If pitch of the screw is P, then what is the distance traveled by the load in one revolution? As you know, what is the pitch? What is the pitch? So pitch is nothing but the distance between two successive threads. The axial distance between two successive threads is known as the pitch. So whenever you will give a one revolution to the lever, so what will happen? The load will travel equal to the pitch. Now, this term, that distance traveled by the load will be equal to the pitch. That is the the axial distance between two successive threads. But it will not always be small p. Why? Because the distance traveled by the load in one rotation will be equal to lead. Now, what is the lead? Because lead is defined as, so this will be equal to lead. What L represents? So L represents the lead here. L represent the lead, and lead is what? Lead is nothing but it is the axial distance traveled in one revolution. How we can develop a relation L and P? So L is equal to NP. Now what is the N? So N is the number of start. N is equal to number of start. That means if it is a single start screw, then lead will be equal to P. If it is a double start, so N will be equal to 1 for single start. N will be equal to 2 for double start. N will be equal to 3 for triple start. L will be equal to 3 for triple start. So in this way, we can calculate the velocity ratio. In this way, we can calculate the velocity ratio. Is it okay? So now, will be equal to nothing but it is a 2 pi L of screw. So this is one way. This is one way to calculate. This is the second way to calculate the efficiency of screw jack. So we have seen two formulas. First one, tan alpha divided by tan phi minus alpha or tan phi plus alpha. And what is the second relation? So second relation is nothing but is efficiency is equal to mechanical advantage divided by the velocity. Is it okay? Fine. So now this part is over. So keep one note here. Sorry. one note here that on the basis of efficiency, how we can calculate if efficiency of a screw jack is less than 50%. If efficiency of a screw jack is less than 50%, then screw jack will be a self-locking screw. So this is one note. If efficiency of a screw jack, if you calculate the efficiency of a screw jack, and if you are calculating that the efficiency of that screw jack is what? Efficiency of a screw jack is less than 50%. Given screw jack will be, then the given screw jack will be self-locking screw. Now, if we're talking about the maximum efficiency of a screw jack, efficiency of a screw jack. Here we are talking about the screw jack, not self-locking screw. What? Because if we are talking about the maximum efficiency of a self-locking screw, then it can be 50%. It can be 50%. But here we are talking about the maximum efficiency of a screw jack. So how we can calculate? So see here how we can calculate. So right now I am going to derive the expression for maximum efficiency of a screw jack. Fine. So how we can derive here? So as you know that efficiency we have already derived that it is equal to tan alpha divided by tan phi minus alpha. This thing we have already derived. Fine. Now, so here what we can write? So this is equal to tan alpha. Where can I? So Tarak is asking where can I PDF? Tarak, once this session is for both the session, you will get the link for the PDF notes. Is it okay? So it is equal to eta is equal to efficiency. Sorry, efficiency is equal to tan alpha divided by tan phi minus alpha. So if you want to write, then how you can write in this part? You can write it as sin alpha divided by cos alpha. And for this you can write it as sin phi minus alpha divided by cos, here we are writing for plus cos phi plus alpha. So if we will calculate the 1 minus n, if we are subtracting here 1 minus eta, so what we will get? We will get this will be equal to, when we will cross multiply, so this will be equal to, here it will be equal to sin alpha cos phi plus alpha divided by cos alpha. This will be equal to sin phi plus alpha. Fine. Okay, so here we are subtracting the efficiency from 1 on both sides. So 1 minus eta will be equal to what? This is 1 minus sin alpha multiplied by cos phi plus alpha divided by cos alpha. This is sin phi plus alpha. Fine. So when we will take the LCM, so this will be 1 minus eta is equal to, this is cos alpha sin phi plus alpha minus sin alpha. This is cos phi plus alpha divided by, it is cos alpha sin phi plus alpha. Fine. Now tell me, this is cos A sin B and this is sin A cos B. So what is the short form of this formula? Cos A sin B and sin A cos B. cos A sin B, and this is sin A cos B. So this will be equal to what? So this will be equal to sin cos A minus B. How it is? It will be equal to sin. This will be equal to sin phi plus alpha minus alpha. Na? This is sin A minus B. Na? Is it okay? So when we will so after the solving, what you will get? You will get sin Nithant. So this will be equal to sin phi divided by 2 cos alpha sin phi plus alpha. So just multiply 2 above and 2 numerator and 2 in denominator. So this will be 1 minus L. This is sin phi. This is sin phi. So this will be equal to 1 minus n. This will be equal to 2 sin phi. And what about the 2 cos A sin B? What is the 2 cos A sin B? What is the 2 cos A sin B? So actually when you will solve this term, I am writing the direct expression here. So the I think it will be sin phi, sorry, in the numerator you will get sin phi divided by sin 2 alpha plus sin phi. This thing you will get when you will solve this term 2 cos A sin B. You can see what you can observe. You can observe from here what that efficiency will be maximum. Efficiency eta will be maximum when 1 minus eta will be minimum. The efficiency will be maximum when 1 minus eta will be minimum. Fine. And this term will be maximum when this complete term will be. In this, what I am saying that eta will be maximum when 1 minus eta will be minimum, and 1 minus eta will be minimum when this denominator will be minimum, this denominator will be maximum. Now, so see here, when this value will be maximum, then 1 minus eta will be minimum. Sorry, this 1 minus eta will be minimum and correspond to that eta will be maximum. So when we will get the maximum efficiency, so see here. So what is the condition for maximum efficiency? So from here you will see that phi is what? Phi is the friction and it depends upon the material. So we cannot control this. This is the constant value. So if phi is the constant value, that means this 2 alpha plus phi. This 2 alpha plus phi should be maximum. So from here we can see that what is the maximum value of sin alpha? Maximum value of sine is what? Maximum value of sine is nothing but it is equal to 1. That means that sine alpha. So this is what? Sine. What is the maximum value of sine 2 alpha plus phi? Sine 2 alpha plus phi. Its maximum value is equal to 1. That means you can say that its maximum value is equal to sine 90 degree. So from here what you will get? You will get 2 alpha plus phi is equal to 90 degree. That means alpha is equal to what? Alpha you will get 90 minus phi by 2, and this is the condition for maximum efficiency. When the helix angle will be equal to 90 degree minus phi by 2, correspond to that the efficiency will be maximum. So this is what? This is nothing but this is the condition of maximum efficiency. Condition of maximum efficiency. So when you will calculate the alpha from here, just put in the above formula and from there you will get the maximum efficiency. So keep this formula in your mind, and so if you will put this alpha in the above formula of efficiency. What is the simplified expression you will get? So keep this thing in your mind. There's maximum efficiency. Maximum efficiency means efficiency correspond to this alpha value. So correspond to this alpha value, what maximum efficiency you will get. So after simplifying the relation, you will get 1 minus sine phi divided by the 1 plus sine phi. So this is the condition for maximum efficiency. Fine. This is the condition for maximum efficiency. Sorry, this is the maximum efficiency. This is the condition for maximum efficiency. And what is the efficiency we have already discussed. Is it okay? So this is all about the concept of screw. The question you can get from this topic, and the question that you can expect in the examination from this topic only. So what are these topics? So these topic nothing but the load required, the effort required to raise the load, the effort required to lower the load, what is the efficiency, what is the maximum efficiency, what is the self-locking screw, and what is the overhauling screw, what are the condition for self-locking and overhauling. And with this concept you can get the question in your examination. Now we will see some question on this topic, and after that we will start our new application part of friction, that is the belt. Fine. So just tell me the answer. I am discussing the question here. So what is the question? I am showing on the screen. So question is this. Now first question is, in a screw jack, I am copying this question. Fine. Okay, so first question is, in a screw jack, the effort required to, in a screw jack, fine. So this is the question. So question is, in a screw jack, the effort required to lower the load is, options are less than, equal to, more than, or none of these. So tell me the answer. In a screw jack, to lower the load is less than, equal to, more than, or none of these. So tell me the answer. Yeah, very good, Vinay. As we have already that P is equal to D by 2 L W tan phi minus alpha, This condition we have seen for lowering the load, and for raising the load this condition is alpha. And when the tangent of angle value decreases, the total value decreases, and when the tangent of any angle increases, the total value increases. That means for the effort required to lower the load is less than the effort required to raise the load. Fine. Now for the self-locking screw, the efficiency must be, for the self-locking screw the efficiency must be, for the self-locking screw the efficiency must be. Tell me the answer. Yeah, Nitan. Actually, Vinay, it is not 50%, because 50%, if it will be equal to 50%, then it is a limiting condition. We cannot say that either the screw is self-locked or the screw is overhauled. So the condition is what? For a machine to be self-locking, the efficiency should be less than 50%. Is it okay? So Nihant, Nihant, your answer is correct. So the answer will be less than 50% because that is a limiting condition 50%. If it will be equal to or greater than, we cannot conclude that the screw will be self-locked. So the condition for self-locking machine is its efficiency should be less than 50%. Is it okay? So that this is a confusing question. That's why I put here. So the efficiency should be less than 50%. That is the answer. Okay. Any doubt? Fine. Okay. Now see the next question. So next question is what? This is the question. So just solve this. Just try to solve this question. So in the question, see what is here. So first question is solve. I'm solving this question, and the second question, please try to solve you. Fine. So what is the first question? So I'm solving this question here. So just see the concept, and after that you can try for the second one. Fine. So what is the question? Question is saying a load of 2 kilonewton. What is this 2 kilonewton? This is the load that is being raised. So W is equal to 2 kilonewton. That means we can write it as 2000 Newton. Is it okay? Fine. Now having threads of 10 mm pitch. And so what is the pitch? So pitch is given 10 mm. Pitch is given 10 mm. Is it okay? Now the efficiency of the jack is 50%. So efficiency is what? Efficiency of the jack is given 50%. That means it is given 0.5. Determine the effort applied at the end of the handle of the 50 centimeter length. Can anybody tell me what is this? What is the 50 centimeter here? Notation for 50 meter. Anyone? Please respond now. What is the 50 centimeter here? Length. How we can represent this length? What is the terminology to represent this length? P, N, K, J, A. How we can write lever length? Exactly. This is the lever length. And what we assume the lever length? The lever length we assume the capital L. So capital L is given here. That is 50 centimeter. As you can see here, in the question, he is not discussing about the helix angle and he is not discussing about the coefficient of friction. That means we will not use the formula of tan alpha divided by tan phi plus alpha. In the question, because he is not discussing about the coefficient of friction, he is not helix angle. So now we have one more formula. What is that? So eta is equal to mechanical advantage. Mechanical advantage is what? That is W by P divided by the velocity ratio. So velocity ratio is what? That is the 2 pi L divided by lead. Because in the question it is not mentioned that it is double start, triple start. So we are considering that is a single start screw. That means it will be equal, it will be multiplied by small p. Now efficiency is already given. What is this? So this value is 0.5. And what about the load? That is 2000 Newton. And what about the pitch? So pitch is given 10 mm. That means 0.01. Is it okay? So it is 0. What about the effort? He's asking for the value of effort, and it is 2 into pi into what is the lever length? It is given 50 centimeter. That means it is 0.5. So from here you can calculate the value of effort. Please tell me the answer. What is the answer you are getting? What is the answer you are getting? Please tell me the answer. Yeah, 12.73. Yes, you are getting 127. How you are getting 127? Let me calculate this. Yeah, 12.73. Began. Very good. So answer is nothing but it is 12.73. That is 2000 multiplied by 0.01. And it should be divided with 0.5 multiplied by 2 into pi into 0.5. So the answer you are getting, you should get 12.73 only. Right? So okay, now yes, it is correct. It is 12.73 Newton. So keep this thing in your mind. If in the question of Screwjack, the value of helix angle and the value of and the information regarding friction is not given, then please do not use the formula of tan alpha divided by tan phi plus alpha or tan phi minus alpha. Fine. So in that condition, use the formula of mechanical advantage divided by the velocity. So this is the first question. Now this is the second question. This is actually in by seeing you will feel that this is a lengthy question, but all the information are given here. Please solve the first question, and I am giving you the second question as a homework. So please try to solve this question. And because the concept is similar, only the sign difference is required. So please tell me the value of effort required to raise the load. Because this is lowering the load. For A part, he is asking what is the effort required to raise the load. So please give me the answer. Each and every data is given here, and as you can see here, the mean diameter is given. So what is this? This is the di, d naught, or d. What is this value? 6 centimeter is what? Inner dia, root dia, nominal dia, mean dia. What is this? Yeah, very good, Vinay. This is the mean dia. So just put in the formula and tell me the answer, please. And after this, this topic will be over, and we will move to the next portion. That is nothing but it is next portion is belt drive. Fine. So belt drive is already a very small topic, so we will discuss about that, and later on we will discuss about the Lagrange's equation. Is it okay? Please hurry up, tell me the answer. So yes is getting 9.21. Yes is getting 9.21. So I am writing here. Please tell me more answer some. Are you getting the same or you are getting the different answer for A part? 9.21. This is the p value. I think each and every data is given. Then why are you taking so much time? Is there any problem with this question? Vinay, Vigyan, Nitan, Nihant. I am waiting for the response. Please hurry up. So right now I am starting to solve this question. When you will solve, please post the answer in the comment box. So here he is asking, find the effort required to apply at the end of handle fitted to the screw head of a screw jack to lift a load. It is clearly mentioned that the question is related to the lifting of load. So what is the magnitude of load here? So the load magnitude of load is given here 1500 Newton. And what about the length of the handle? That means it is nothing but the lever length. So it is given as 70 centimeter. That means we can write it as 0.7 meter. 0.7 meter. Now mean dia means that is capital D. So capital D is given here 6 centimeter. That means we can write it as 0.06. 0.06. And what about the pitch? So pitch is given as 0.9 centimeter. That means 9 centimeter. That means it is nothing but 0.009 meter. Is it okay? Now coefficient of friction. So coefficient of friction nu is given here. So coefficient of friction mu is given here. So mu is what? Mu is given here 0.095. So mu is given here 0.095. Okay, so now I got it where you are facing problem. Okay, so I'll solve here. So here, can you tell me with what value you are facing the problem? Anyone? And please yes, tell me how you get the alpha, because alpha is not here, na? So can you tell me how you can get the alpha here? Please tell me. So please tell me, rest of the people, are you facing with the problem of value of alpha only, na? So mu is given 0.095. That means what is the value of 5? So value of 5 is nothing but it is tan inverse mu. So tan inverse mu. So from here you will get, when you will take the tan inverse 0.095, that means 5 you are getting 5.42. So 5 you are getting 5.42. Fine. Now, so see here, actually sometime you will see that alpha is not given, or most of the time you will see that alpha is not given. Then how you can calculate the alpha here? So see, as you know, during one turn what will happen? So during what turn, how much length you will cover, how much horizontal length you will cover? So it will be simple equal to AB. What horizontal length you will cover in one rotation? That is AB. So it will be equal to pi d. This pi d is what? Here d is what? This is nothing but this is the diameter of a screw. Here we are not talking about the lever, because when you will see the derivation part, so in derivation part you will see, because you can see that this is the screw, fine, and these are the threads. So loading condition is what? Loading condition, that means, as you know, the threads of the screw is in connection with the thread of the nut. So as you see, whole load is transmitted with the help of these threads only. So we can consider this as a problem of load on an inclined plane. Then how you can calculate this alpha? So how we can calculate that, I am telling here. As you know, let us assume that d is the diameter of this screw, d is the mean diameter of this screw. So what is the horizontal distance that you will cover in one complete turn? So that will be equal to the 2 pi r, that means it will be equal to pi t. And what is the vertical distance you will cover in one turn? So it will be equal to the pitch if it is a single start, otherwise it will be equal to lead. So what is the total distance you are covering? So the total distance is nothing but this. Fine. So if you want to calculate the alpha, so alpha will be equal to what? So when the alpha is not given, so alpha is always calculated with this relation. So tan alpha will be equal to L over pi d. So with this concept you can calculate the value of alpha. So this is important. Keep this as a formula. Most of the time in problems of screw jack, when alpha is not given, you can calculate the alpha with this relation. Fine, because this is the helix angle, this is the horizontal distance here you are covering. In the same time, this is the vertical distance you are covering. So what is the total distance? This is nothing but equal to AC. So what is the inclination with the horizontal? That is nothing but alpha. Tan alpha is equal to L pi dm. Yeah, d is the mean dia here. Very good, Vinay. So yes, is saying tan inverse of lead by pi d. Very good. So I hope now you will get your answer, because all the values are here. So from here you will get the value of alpha. Just put the value in the relation P equal to D over 2L W tan phi plus alpha. When you is given in this relation, you will get the effort required. Is it okay? I hope now you will get the answer. Is there any problem with this question? Tell me yes or no. Is there any problem with this question? Now you will get the answer. Okay, fine. So in this way you can calculate the effort required to raise the load. In the second part, he is asking what is the instead of raising the load, same load is lowered. So in this second case, he is asking P2. P2 is what? That is the effort required to lower the load. That means all the values have given, just you have to use the minus sign, and after putting the minus sign, you will get the answer. So as yes is suggesting that P raising and he is getting, that is 3.02 Newton. So if calculation is correct and all the values are correct, then I hope that you are going to get these values only. Fine. P effort is nothing but 9.21 Newton, and effort required during lowering the load, it is 3.02 Newton. And from this formula, as you can directly see, whatever we have seen in first question, that effort required to lower the load is less than the value of effort required to rise the load. So here, for lowering the load, the effort required is 3.0 Newton, and for raising the load, the value of effort is 9.2 Newton. So with this, the screw jack is over. Now we are going to cover the two more important parts, that is belt drive, and later on we will discuss about the Lagrangian Equation. Fine. So what is the belt drive? Can anybody tell me what is the belt drive and why it is used for? Anybody? What is the belt drive and why it is used for? Because there are only 2-3 relations, and those 2-3 relations are more than sufficient. And you will be surprised that this belt drive is already in GATE syllabus before 2000. This belt drive is the part of was the part of GATE syllabus before 2000. So if you will see the papers of before GATE 2000, then you will find the question from those topics. But right now it is again added syllabus, so you can get similar type of problem in upcoming examination. That's why I picked some question on this topic that we will discuss in this class. Fine. So can anybody tell me what is the belt drive? So belt drive, okay, nobody is responding. Okay. Flexible link used to transmit power from one pulley to other at a medium distance apart. Very good. So yes is saying actually what is the belt drive. So as all of you know, belt drive is nothing but it is a medium for transmitting the it is a method of transmitting the rotation, motion, and the power. So it is a drive that is used to transmit motion and power from one shaft to another, from one shaft to another, Now when it is required only when input and output shafts at a large distance. This is required only when the input shafts and output shafts are at large distance. But it is not required. We cannot use this drive. When exact power transmission is required. When exact power transmission is required. So this is one important point, that most of the time we will use the belt drive. Why we will use the belt drive? Because it is less costly, and in belt drive, when we are transmitting the power with the transmitting the power and motion with the help of belt drive, there will be less vibration and less noise. So mostly we prefer the belt drive. But whenever the exact power transmission or motion transmission is required, we cannot go for belt drive. Can anybody tell me why we cannot use the belt drive when exact power transmission is required? Anybody? Why we cannot use the belt drive when exact power transmission is required? Very good, yes. So yes is answering that due to slipping. Now what is the slipping phenomena? What is the slipping phenomena we will discuss here. So actually understand one phenomena, that in case of belt drive, when we operate at higher speed and higher loading condition, what happens, there is the velocity ratio do not remain constant, and that is the when we operate at a high speed and high loading condition, in that condition the velocity ratio do not constant. When the velocity ratio do not constant, that means whatever we are supplying, whatever motion we are producing or we are supplying at one shaft, and whatever we want to achieve on the another shaft, the same thing we cannot achieve. Why? Because of slipping phenomena. Now what is the slipping, we will discuss in some minute. So now see what is the belt drive. So in belt drive there's two pulleys. There is a two pulley, one is the driver, one is the driven. So this is one pulley, fine. So this is one pulley and this is another pulley. So this is the belt. So this is the belt. Suppose this is the rotation and this is the driver pulley and this is the driven pulley. So this is the arrangement. So on which concept belt drive works? So belt drive works on the principle of friction. Belt drive works on the principle of friction. This is the principle. This is the principle. Now what happens? As you can see here, when the belt passes over the surface of one pulley, so in that condition what happens, there is the friction, their friction occurs in between the surface of pulley and the belt. So due to power from one shaft to another. This is input shaft, or we can say that this is the input shaft. I think there was a connection error. Fine. So where was I am? So as I said, that in case of pulley, what happens, that surface of the belt, lower surface of the belt comes in the contact with upper surface of the pulley, and due to the relative motion, when there is a tendency of relative motion, a friction comes into the picture. So the friction is so sufficient that it do not allow the relative motion. That means they move as a whole. So whenever there is a tendency of relative motion, whenever there is a tendency of relative motion between the surface of belt and pulley, what happens? They move as a whole, and in the same way they transmit the motion or power from one shaft to another. Now, what is the phenomena of slipping? So it is observed that at high speed, at high speed and at high velocity, at high speed and high loading condition, at high speed and high loading condition, it was observed what happens. It was observed that the pulley performs the forward motion without carrying the belt. That means the relative motion is occurring in between the belt and the pulley. What I am saying, at high speed and high loading condition, what happens? This pulley moves forward without carrying the belt. That means if it is not carrying the belt along with it, so what happens? The relative motion occurs in between. Pulley and the belt. So in that condition, that phenomena is known as the slipping. Same thing happens at the driven pulley also. Sometimes it happens that belt performs the forward motion without carrying the pulley. Without carrying the pulley, belt performs the forward motion in case of driven pulley. And what happens at the driver? The driver pulley performs the forward motion without carrying the belt. And such phenomena is known as the slipping. And whenever the slipping happens, the exact velocity ratio cannot be obtained. Now come to the velocity ratio, and after that I will give you the definition of slip. Fine. So what is the velocity ratio? Velocity ratio. So velocity ratio is nothing but, so what is the velocity ratio? It is nothing but, it is the ratio of driver to driven pulley. It is the ratio of speed of it is the ratio of speed of driver pulley to driven pulley. Driver pulley to driven pulley. Driven pulley. So if we want to write, because let us assume we are considering that R1 is the radius of driver pulley and R2 is the radius of driven member, and if it is rotating at omega 1 angular velocity and it is rotating with omega 2 angular velocity, can anybody tell me what will be the sense of rotation both the pulley? Either it will be same or it will be different. This is a simple question. In this given belt drive, what will happen? If input is rotating clockwise, so output will rotate clockwise or anti-clockwise. Both the pulley will have same sense of rotation or opposite. So very good. As you can observe, if it is an open belt drive, so if the arrangement of belt and pulley is something like this, then in that case, what will happen? You will get the same sense of rotation. Same sense of rotation. That means if we are considering that there is no slipping happen, so what will happen? Whatever will be the potential velocity of this pulley, same will be the velocity of that belt. So how we can write? We can write V1 is equal to what? V1 is equal to pi d1 n1. This is equal to what? Pi d1 n1 in terms of revolution per minute. And if we want to write, because there we are assuming that the slipping is not happening here, so at this point also, what will be the velocity? What will be the velocity? So what is the circumferential velocity? V2 is equal to pi d2 n2, or we can write it as r omega. V is equal to r omega. That means it is d1 by 2 omega 1, and it is what? This is d2 by 2 omega 2. So from here you can see, as you know, because this we are considering that there is no increment or decrement in the length, or no shortening or elongation inside the belt. That means we can say that V1 is equal to V2. So if we want to calculate the velocity ratio, then what is the velocity ratio? It will be equal to, velocity ratio will be equal to d1 by 2 omega 1 sorry, here the speed of the driver speed will always be in terms of rotation. It will be equal to omega 1 divided by omega 2. Fine. So this is the velocity ratio. But if we want to see here, as you know, that v1 is always equal to v2. Why? Because we are considering that there is no elongation and no shortening inside the belt. So the velocity inside the belt will remain the same. That means v1 is equal to v2, v1 equal to v2. That means we can say that d1 omega 1 equal to d2 omega 2. So from here we can calculate the value of omega 1 by omega 2. So what is this? So this is nothing but it is equal to d2 by d1. So if you want to calculate the velocity ratio, so it will be equal to omega 1 by omega 2, or it will be equal to d2 by d1. Whatever information will be given to you, with the help of that information, you can calculate the velocity ratio. Now, one more thing is important here. Just to identify the tight side or the slack side. Can anybody tell me which side will be tight side and which side will be slack side? We are naming this side as 1 and this side is 2. So I just interested to know, I just want to know that which side is a tight side. Give me the answer. Sense of rotation is already given. Sense of rotation is already given. Just tell me the answer. Which side is a tight side? So Nihant is saying top side is tight side, sir. So I am waiting for another responses. Please post in the comment box. So when I am saying that one is the tight side, okay, and because there is much confusion about that which side is tight side and which side is slack side. Slack means loose side. Fine. So most of the people are answering that tight side will be 1, and Sanjay is saying that tight side will be 2. Okay, so we will see how we can identify. Okay, so it is a very simple concept. Now see here, and you will not forget this concept in your whole life. Let us assume this is a driver pulley. You know very well this is a driver pulley. Just tell me, when suppose there is a input is supplying through input is supplied through an engine, and it is transmitting to another machine. Fine. So just tell me when the machine will start. So after starting of machine, after starting of machine, the speed of the driver pulley will decrease or increase. Or I want to know when the driver is coupled with the driven member. In that condition, the speed of the driver pulley will increase or decrease. Just tell me this. When driver is coupled with a driven member, then speed of driver will increase or decrease. Yeah, so when I am saying that it will decrease, okay, fine. So it will decrease. Now see here, if you know this, that it will decrease, that means it is rotating in this direction, but its speed is decreasing. Its speed is decreasing, that means the net torque will be opposite. The net torque will be opposite to the rotation, because if our body is accelerating in this direction, its motion is decreasing. That means we know that the net force is acting in opposite to the motion. So if its a rotation is in this direction, that means the net torque is acting in opposite direction. That means here one torque is here and one torque is here. Now, so if we will use T1 here, if we are denoting T1 for maximum and if we are denoting T2 for minimum, so that means if it is maximum, it is minimum, so the net torque will be in clockwise, motion in clockwise, and net torque will be in clockwise. That means the speed will increase. That means this is wrong. So if T1 will be in this direction, T1 will be in this direction, and T2 will be in this direction. So this is maximum, this is maximum, this is maximum, and this is minimum, this is minimum. Then only our concept will satisfy that after coupling with a driven member, its speed is going to decrease. So this side will be tight side and this side will be slack side. Same concept you can obtain from the driven pulley. Now, how you can obtain? As you know, when the driven pulley is coupled with the driver, so its velocity will increase and it is rotating in this direction. Because its velocity will increase, that means the net torque is also acting in this direction. So if the net torque is also acting in this direction, that means this torque will be maximum torque and this torque will be minimum torque. Is it clear to you? Is it clear to you? I hope right now you will not forget this thing, that how you can identify. So there is no need to see that what is the sense of rotation, because in this case sense of rotation like this on driven pulley. So for that you have to identify that in case of a driver the maximum will be opposite to sense of rotation, and in case of driven it will be along the sense of rotation. So forget about that, just see the driver. So the speed of the driver will decrease when it is coupled to the driven. So the net torque will be opposite to the motion, and with that concept, mark your tight side and your slack side. Is it okay? Fine. So in the given drive, I hope now it is clear to you that this side will be tight side. This is T1, and this side will be slack side. This will be T2, T2. Fine. Now, one more thing. Assume that the surface of the pulley is frictionless. If the surface of pulley is frictionless, why there is a variation in torque? There is a variation in torque due to the presence of friction, because whatever friction is present at the contact surface, that is causing the reduction of this torque. For example, suppose if there is no friction, in this, or it is mentioned that the surface of the pulley is smooth, in that condition both the torque will be same. If both the torque will be same, now tell me, is there any resultant torque? No, there will be no resultant torque. So if there will be no resultant torque, that means it will not transmit the power or motion, because in that condition both the torque is same. So if both the torque is same, then in that condition it is not capable to transmit the motion. Is it okay? So this is all about the concept of friction. Now we will see how we can calculate the tension inside the pulley. So there is one relation. Before that relation, I want to explain torque on driver pulley. Torque and driver pulley. What is the net torque on driver pulley? Anyone can tell me what is the net torque on driver pulley? Sanjay is asking which side arrow had, then that side is also select side. Which side arrow had, then that side is also select side. I am right or wrong? Sanjay is saying which side arrow had, then that side is also select side. Okay, so Sanjay, I think you want to say that in driver pulley this side is arrowhead. In driver pulley this side is arrowhead. That's why it is a select side. Is it? Or you want to convey same thing? That you are saying that this side is arrowhead, so this side will be select side. I am getting right thing, or I am misinterpreting your comment? Please tell me. You want to same thing, na? Yes. So, okay, Sanjay, if you are saying that which side has the arrow, that side will be the select side. Now tell me, in this case, the arrow side is here. In driven pulley, the arrowhead is here, na? In this pulley, the arrowhead is here, but this is the tight side, na? Then how you can say that if the select side will be in the direction of arrowhead side? You cannot conclude, na, because in this condition the sense of rotation is like this. So the head of the sense of rotation will be in this direction, but in this direction the side is tight side on. Is it okay? I hope this is clear to you. Fine. Okay, So what is the net torque on driver pulley? So this is the force, and when we talk about the torque, so torque is nothing but it is the resultant force. So that is T1 minus T2. And what about the radius? So radius of this driver pulley is what? Driver pulley is R1. So it will be equal to R1. In the same way, if you want to write the driven net torque on driven pulley, then how you can write? You can write it as T1 minus T2 into R2. Is it okay? So this will be the net torque on driven pulley. Fine. Now, so these two terms have been if you want to write the power transmitted. So how you can write power transmitted? Either you can write, okay, so power transmitted you can write T1 minus T2 into omega. And what is the omega? So T1 into, this is the force. This is the force only. Na? So this is the force multiplied by velocity. What is the velocity? So velocity is nothing but pi1 d1 n1 by 60, and or you can use pi d2 n2 by 60. With this two term, you can calculate the velocity. Just put it here. If you have the value of T1 and T2, then you can get the power in the belt and pulley. Is it okay? Now, there is one more term that how you can calculate the tension. So most of the time, only one tension will be given to you, and one tension you will have to calculate. So there is one small derivation part for this, that is the ratio of tension in belt drive. Ratio, I am writing here different color. So I am not going to drive that expression here because that is redundant part only, and you are very familiar with that derivation part. Fine. So what is the ratio? It is the ratio of tension in belt drive. Ratio of tension in belt drive. So what is the ratio of tension in belt drive? So it is nothing but T1 y T2 equal to e raised to the power mu theta. So this is very important relation. So what is this? T1 is the maximum tension. T1 is equal to maximum tension, or the tension on tight side, maximum tension. T2 is equal to minimum tension. Now, what is the mu? Mu is nothing but coefficient of friction. And what about the theta? So theta is nothing but it is the angle of overlap. Now, what is the overlap? Angle of overlap means it is that angle on which the belt is overlapped over the pulley. For example, if you want to see here, for example, this is the center. So on this angle, the pulley is overlapped on the pulley. So this angle theta will be what? This will be the angle of overlap. So just put the theta here, and this theta will always be in radian. Do not put in degrees. So just put it here. If one tension is given to you, then you can easily calculate the another tension. Once you have the value of tension, you can calculate the net torque on driver driven, or you can calculate the power transmitted. So this is all about the concept of belt drive. Now we will see 2 to 3 questions, and after that we will start the Lagrange's equation. How we can use the Lagrange's equation in dynamic problem. Is it okay? Fine. Now, so right now I am giving one more definition, that is the slip in a belt. Slip in a belt. So when the friction is inefficient, when the friction is insufficient, friction is insufficient, then driver pulley, then driver pulley have forward motion without carrying the belt, This phenomena is known as slipping. This phenomena is known as slipping. This phenomena known as slipping. So on driver pulley, what happens? On driver pulley, pulley performs the forwarded motion without carrying the belt. And what happens on driven pulley? On driven pulley, belt moves without carrying the pulley along with it. Fine. So in such a way, the slipping phenomena happens, and whenever the slipping phenomena happens, the exact motion transmission or exact power transmission is not possible. And so slip is always given in terms of percentage. It is always given in terms of percentage. So for example, if slip percentage is given, then how we can calculate the velocity ratio? So it is equal to d2 by d1 1 minus s over 100. 1 minus s over 100. If slip is not given in terms of percentage, then we have to use s divided by 100. If it is given in percentage, so directly put it here. So with this formula, we can calculate the velocity ratio. Is it okay? So this is slip in belt percentage. And what is the effect of slipping? It reduces the velocity ratio. It reduces the velocity ratio. Is it okay? Now there is one more phenomena, creep in belt. I hope you have heard this term, creep in belt. So I am not giving the definition for it, but I am instead of that I am explaining this term, creep of belt. Sometime you may get the theoretical type of question from this concept. So what is the creep of belt? So can anybody tell me what is the creeping phenomena? I hope you have studied this term in strength of material, because you all are mechanical students. So you studied this concept of creep in strength of material or in manufacturing also. Maybe in manufacturing, otherwise short you studied this concept in strength of material. Can anybody tell me what is the creep? What is the creep? It is not cheap, it is creep. Just tell me. Okay, so I'll tell you what is the creep. I hope you have heard when any material is subjected to a constant load for a longer period of time. Whenever material is subjected to a constant load for a longer period of time, in that condition, some permanent deformation at elevated temperature or at high temperature. When a material is subjected to a constant load for a longer period of time at higher temperature, in that condition some deformation occurs in that material. That is known as the creep. So when I am saying progressive permanent deformation due to constant stretch which is below the elastic limit. Very good. So this definition is correct, but I think that you didn't mention the temperature term in your definition. But temperature is because it is dependent on temperature also. So creep phenomena is temperature dependent. So the definition is like that. It is a progressive permanent deformation under a constant stress at elevated high temperature. So, that is known as the creep. So same thing happens here. As you can see that in case of belt drive, belt each and every cycle suffers to the tensile as well as the compressive force, or you can say that belt each time passes from tight side or the slack side. So when it passes through the tight side, it is elongated, and when it passes through the slack side, then it is shortened. So due to this elongation and shortening phenomena, what happens? The relative motion occurs between the pulley and the belt. What happens? So due to this elongation and shortening phenomena of the belt, what happens? The relative motion occurs in between the pulley and the belt, and this is known as the creep of the. Is it okay? Any doubt? So due to continuous elongation and shortening, because belt passes through the tight side and slack side, so there is continuous elongation and shortening happens, and correspond to that a relative motion occurs between pulley and the belt, and that phenomena is known as the creep of belt. And what is the effect of creep? So the slip reduces the velocity ratio, but it affects the speed of driven pulley. It affects the speed of driven pulley. So with this, all the concept of belt is covered, which is important for the GATE examination. Fine. So right now we are going to see 2 to 3 problems, and later on we will start the Lagrange's equation. Is there any doubt up to now? Is there any doubt? If it is there, then you can ask here. Fine. If it is there, then you can ask here. Okay. If there is no doubt, then please try to solve this question. And this is a very easy question. So same type of question is asked in the GATE examination, and below this all the questions that have been asked in the GATE examination. So first try to solve this question, tell me the answer, and later on we will solve the question that already asked in previous year GATE examination. Fine. Please hurry up because we have very little time. So just solve this question, and later on we will see the GATE problem. So a belt is running over a pulley of diameter 120 centimeter at 200 rpm. So a belt is running over a pulley of diameter 120 centimeter at 200 rpm. So right now I am going to start to solve this question. So one who have already solved this question can give your answer in the comment box. Fine. So what is this? This is nothing but this is the diameter of pulley. That means 1.2 meter. And what about the speed? So speed is given as 200 rpm. What about the angle of contact? So angle of contact, that is nothing but 165 degrees. And what about the coefficient of friction? So coefficient of friction is given 0.3. What about the tension? So maximum tension is mentioned. Which value is this? Maximum tension in the belt is 3000 Newton. Anybody tell me? Which tension is this? Which tension is this? Okay, very good, Nihan. So it is nothing but it is T1, maximum tension. So T1 is already given. Almost each and every data is given because he is asking what is the power transmitted. So power transmitted is what? Power transmitted is equal to T1 minus T2 multiplied by V. And what about the V? So V is nothing but V is equal to, so here I am calculating V. So V is equal to pi D1 N1 divided by 60. So it is pi, D is what? That is 1.2. What about the N1? So N1 is given 200 RPM. And what about the 60 is doesn't mean. So it is 60 only. Fine. So from here you will get the value of V. Now, what about the T2? So we have one relation between tension. So T is equal to E power mu theta. So mu is already given 0.3. And what about the theta? So theta, what is the value of theta? So we will put 165 here. So what we will put? Theta is equal to, what we will put? Theta is equal to, what we will put? Theta equal to, okay, so most of you are getting 21.81 and Nihant is getting to 1.798 watt. I think this answer is watt, so it is again to 21.79. So when I sing, Vinay, you are giving me the answer or you are giving me the value of theta. So what is here? In this case, the theta always put in radian. Do not commit this mistake that put in degree. So convert it in radian. So please, I am writing with this term with red pen. So Vinay is saying it is the value of theta. So I hope the value of theta in radian is nothing but 2.879. Whatever Vinay is giving me. So I'm putting here, from here you will get the value of T2. Once you will get the value of T2, just put it here because T1 is already given. T1 is already given, that is 3000 Newton. And when you will put all these value here, so you will get the answer. So most of the people giving answer me as 21.79 something. So answer will be 21.79 kilowatt. Fine. So this is the answer only. Is there any problem? Is there any problem? So can we proceed? Can we proceed for the previous gate question? Okay, fine. So now what is the question? This question was asked in gate 2009, gate 1998. The difference between the tension on tight and slack side of the weld drive is 3000 Newton. 3000 Newton. If the weld speed is 15 meter per second, the transmitted power in kilowatt is. And this is the standard of gate question. Similar type of problem will be asked in the gate examination. So whatever we have discussed, I think that is more than sufficient for the gate examination. So please tell me the answer. What is the answer? Yeah. So yes is saying it is nothing but 45 because already T1 minus T2 is given here. So T1 minus T2 is given here, that is 3000, and the belt speed is given. Belt speed is given 50 meter per second. So directly multiply 3000 multiplied by 15. So you will get the answer. So P equal to 3000 multiplied by 15. You will get 45,000 watt, or you can say that 45 kilowatt. So very good, Kathy. Very good, Nihan. And very good, yes. You gave me correct answer. So answer is nothing but option A. Now see one more question. This question was asked in gate 2000. Gate 2000. The ratio of tension on the tight side to on the slack side in a flat weld drive is. Tell me the answer. So what is the answer? Tell me the answer. The ratio of tension on the tight side to that on the slack side in a flat belt drive is. Okay. So Binay is saying B, Nihant is saying B, Yes is saying B, and that is the correct answer. Why? Because we have already seen one expression, that is what T1 by T2, and Khyati also giving answer option B. Fine. So T1 is equal T1 by T2 equal to e raised to the power mu theta, and he is asking the same expression. So and the ratio will be equal to an exponential function of product of coefficient of friction and the lap angle. So option B is the correct answer. Fine. Now, actually, this is the question that was because before 2000 there was some conventional question. And this question belonged to that conventional category. Now, this concept, this question is related to the calculation of the reaction force on the drive pulley. So what is the reaction? As you know, the shaft is mounted over the bearing. So bearing is nothing but it is a hinge support. So when we will remove the pulley from the support, then we will get one reaction in y direction and one reaction in x direction. So I am here telling you the approach for this question because the time is very less. So I am telling you the complete approach. Just put the value and you will get the answer. I will give the answer to you also. Fine. So now, as you know that he is interested to know the reaction at the support. And as you know, because shaft is mounted on the bearing support, so there will be two reactions. So when we draw the free body diagram, we will impose two reaction here. Now, in the question, T is already given. That means power is given. It is 1.5 kilowatt. 1.5 kilowatt, and the coefficient of friction mu is given 0.25. Mu is given 0.25. And what about the other data? The lap angle theta is given 159 degrees. So convert it into radian. Fine. Now, apart from this, the drive pulley is rotating in a clockwise direction with a linear belt velocity of 3.75 meter per second. So it is given 3.75 meter per second. Is it okay? So if it is given, that means you have the relation P is equal to T1 minus T2 into V. So from here P is given, V is given. That means from here you can calculate the T1 minus T2. I think you can get this. Now, and you also know the relation in between T1 and T2. What is this? This is nothing but e raised to the power mu theta. So mu is given, theta is given. So from here you can also get the relation in between T1 and T2. Once you will get the relation in between T1 and T2, then just put this value of T1 in this equation. Then you can get the value of T1 here and T2 here. T2 here. Fine. Now, as you see that it is rotating in clockwise direction with linear velocity. It is rotating in clockwise direction. So it is rotating in this direction. That means it is T1 and this is T2, because we are assuming that this is a driven pulley. So it is T1 and it is T2. Now, so T1 and T2 you have already calculated. On this pulley member, two forces are acting, that is T1 and T2. Can you calculate the reaction? Yes, you can calculate. How you can calculate? See here. As you know the equations of equilibrium. So what are the equations of equilibrium? Summation of fx is equal to 0 and summation of fy is equal to 0. Yes, we can use this, and by using this we can calculate. But there is a problem. In order to resolve these two tension, we need the inclination of the tension either with the horizontal or with the vertical, and it is very easy to find. How it is easy to find? Complete angle is theta. So complete angle is theta. That means this angle will be theta by 2. If this angle is theta by 2, this angle will be theta by 2. So if this angle is theta by 2, that means when you will draw a parallel line, that means you can say that this is theta by 2. This is theta by 2, and you know that belt is always tangent to the pulley. That means this angle will be what? This angle will be 90 minus theta by 2. So if this is 90 minus theta by 2, that means this angle will be theta by 2. So T2 is making theta by 2 angle with the vertical, and T1 also making theta by 2 angle with the vertical. Now you can resolve along horizontal direction and vertical direction. You can resolve T2 along horizontal direction and vertical direction. And by resolving the tension by using the equilibrium equation, you can get the value of T1 and T2. Now tell me where you are facing the problem. Are you able to solve it or not? Please tell me. Are you able to solve it or not? Because complete concept I give here, that how you can calculate the T1 and T2. So T1 and T2 is making theta by 2 angle with the vertical. So you can resolve T1 in horizontal and vertical direction. You can resolve T2 in horizontal and vertical direction. On this pulley, use summation of fx0, summation of fy0, and you will get the what? You will get the answer. So what value you will got? So yeah, I am mentioning here that fy you will get fy, or reaction y. Reaction y you will get 72.89 Newton, and reaction x you will get 117.91 Newton. This is the answer only. Please tell me, can you solve it or not? Because complete procedure I told here. Up to here, T1, T2 calculate. After calculation of T1, T2, this angle is nothing but theta by 2, theta by 2. You can easily resolve and just use the equilibrium equation, summation of fx0, fy0, and you get the answer. Okay, fine. Vinay. So I hope up to now your concept of friction is already covered, and the use of that concept of friction in the application problem is already covered. Now we will discuss about what? Now we will discuss about the Lagrange's equation. Fine. This is the last topic of our session. So if you find that this session is helpful for you, so please share this session with your friends also, so that they can also use this session to maximize the chances for getting good marks in the examination. Okay. Right. Now, what is the Lagrangian equation? Actually, the concept of Lagranges is very vast, and this is a part of advanced physics. This is not a basic level physics. This is a part of Lagranges. This is a part of advanced physics. So, how we can solve the problem, and what is the Lagrange's equation, that I am going to tell here now. In Lagrange's equation, you have to use in Lagrange's equation. What we will do, we will use the Lagrange equation to solve the dynamic problem. So first, see what is the Lagrange equation. So please focus your attention here. Please maintain your focus here, because this is a very important part. So what is the Lagrange equation? So Lagrange equation statement is expression is nothing but it is d over dt del L over del Q dot minus del L over del Q equal to 0. This is what? This is nothing but the Lagrange's equation. Right now I am explaining one each and every term here. So what are the term here? L is what? L is nothing but it is known as the Lagrange's function. Lagrange's function. And it is equal to what? So Lagrange's function, it is equal to T minus V. Now what is the T here? So T is nothing but the total kinetic energy. T is what? Total kinetic energy. And what about the V? So V is nothing but total potential energy. Right. So T is minus V. So T is what? T is the total kinetic energy, V is the total potential energy. And what is the Lagrange's function? So Lagrange's function L equal to T minus V. Fine. Actually, my YouTube is disconnected, so please give me 1 minute so that I can connect. Okay. So Lagrange's function is L, and it is nothing but it is t minus v. So whenever you will solve the question, first you have to calculate the Lagrange's function. So before that, you have to calculate the total kinetic energy and total potential energy of the system. So after subtracting the total potential energy from the total kinetic energy, you will get the Lagrange's function. Once you will get the Lagrange's function, put in this equation. Now, what is the q dot here? So q dot is nothing but q is what? First we will discuss about the q, and later on we will discuss about the q dot. Fine. So q is what? Q is nothing but the generalized coordinates. Generalized coordinate. Can anybody tell me what is the generalized coordinates? So what is the generalized coordinate? So basically coordinate system is used to define the position of any object at any instant of time. Now, what is the generalized coordinate? So generalized coordinate is that coordinate which is independent of other constraint. That means sometimes you will see that the x coordinate is dependent on the y coordinate. So if x coordinate is dependent on the y coordinate, then both the coordinate will not be generalized coordinate. In generalized coordinate, both the coordinate means all the coordinates should be independent from the other constraint. So it is something like the degree of freedom. I hope you have studied the concept of degree of freedom in what subject? In theory of machine. In theory of machine, you have studied it is the number of independent motion that a body can perform. So whatever degree of freedom a body have, the same will be the number of generalized coordinate, because that is related to the number of independent motion, and generalized coordinates is related to the number of independent coordinates. So always in a system, generalized coordinate will be equal to the degree of freedom. Is it okay? I hope there should not be any doubt, because you all are the mechanical students, so you are aware with the term of degree of freedom. So it is very easy to find that what are the generalized coordinate. Now, so this is all about the Lagrange's equation, and it can use to solve the any type of dynamic problem, because there are some limitation with the Newton's law. So basically this Lagrange's equation is nothing but it is derived from the D'Alembert's equation. When you will see the this explanation part, this expression, so this expression is derived from the D'Alembert principle, or there are other methods also to derive the Lagrange's equation, but here we are talking about that this expression is derived from the D'Alembert principle. Now, how we can solve the question? So right now we will take one or two example, and with the help of that example, we will try to understand the use of Lagrange's equation, how we can solve. Fine. So, is there any problem with this concept? Because whatever I told up to now, so if you have any doubt, then you may ask right now. Otherwise, I will start to solve the problem. Fine. Just remember only one equation. What is that? This is the Lagrange's equation. And what is the Lagrangian function? It is the difference between total kinetic energy and the total potential energy. And how we can solve the question? So that we will see here. Fine. So see here how we can. So let us consider we are taking one simple example. We are considering one simple example. For example, there is one body. Okay, so asking, sir, what is q dot? Very good question. Because at that time I explained about the q, but I didn't explain about the q dot. Fine. So let us assume we are considering this direction x as generalized coordinate. That means the motion of the object, the motion of the object is along this direction only, and it is not dependent on other coordinate. It cannot move in other direction. So this is our generalized coordinate because it is independent of another coordinates. No. So this is what, in this direction x is the displacement. X represent the linear displacement. So what will be the x dot represent? So x dot will represent the velocity. So q represent the generalized coordinate, because if we will use x, then you may ask a question like this, that sir, is it only for linear system? No, it is not only for linear system. It can be used for linear system as well as the rotational system. So q is the generalized coordinate. Either it may be theta or it may be x, that is the linear displacement. So x is the displacement or q is the displacement, and q dot is nothing but it is the velocity. Fine, I hope so. Just see this problem, and after that this concept will be clear to you. So let us assume there is one ball that is free falling from the surface, that is free falling from a height of h, fine, that is free falling from a height of h, and I am interested to know that what is the acceleration of this ball. And you are very much aware about this concept that when a ball free falls, its acceleration is nothing but its acceleration is equal to the gravitational acceleration. So same thing we will drive with the help of Lagrange's equation. How we can drive? See here. So as you know, we are considering that the motion of the ball is in. So this is our generalized coordinate. So we are assuming that this is our generalized coordinate, that is nothing but x. Fine. So if it is x, so we have already defined our generalized coordinate. That means q is equal to x here. Q is equal to x here. So q is equal to x here. And what about the kinetic energy? So let us assume at this instant. So in this condition, we are assuming that a ball has the mass of m, and at this height, it is at a height of h. So this is h. H is what? This is nothing but our generalized coordinate. So we are assuming that this h equal to generalized coordinate x. And so what will be the velocity at that instant? So at that instant, the velocity will be equal to x dot. Fine. Now, if we want to know what is the Lagrange's function, so for that we have to calculate the kinetic energy as well as the potential energy. So what is the kinetic energy here? So kinetic energy is nothing but kinetic energy will be equal to half mv square. So we can write here half mx dot square. Is it okay? And what about the potential energy? So potential energy is due to the position. We are assuming at this point the potential energy is 0. So there is a positive datum. That means we can write here that potential energy is nothing but mg, what is x? This is the potential energy. So what should be the Lagrange function? So Lagrange function will be something like this: half m x dot square minus mgx. This is the Lagrangian function. We have already find out our generalized coordinates. We have already find out our Lagrange's function. Just put in the equation. So what is the equation? This is d by dt del L over del q dot minus del L over del q, and this should be equal to 0. So just first calculate this del L over del q dot. So when we will calculate del over del q means q is what? That is generalized coordinate. So generalized coordinate is x, then q dot will be equal to x. When you will differentiate, there is no x dot term, so the partial differentiation will be 0, and from here you will get half m into 2x dot. So 2 will cancel out. That means del L by del x dot is what? That is mx dot. And what about the del L over del x? So when you will calculate del L over del x, so this term will become 0, and here you will get minus mg. So now put all the values here. So from here you will get del over del t. This is what? This is mx dot minus mg. This thing we have already calculated. So this is what? This is the time derivative of mx dot. So m is the constant, it will come outside. So when this is capital X, fine. So m will come outside. So what is the time derivative of generalized coordinate x dot? So that means you will get mx double dot. And this is what? This is plus mg. So from here you will get 0. So what is the x dot? X dot is nothing but the acceleration, that minus g. So minus g is what? Minus g is nothing but 9.81 meter per second square. Why we are getting minus? Because we are considering generalized coordinate in upward direction. So minus sign represent that the acceleration is opposite direction. So what will be the acceleration of this object? Acceleration will be equal to 9.8 per second square, and the direction will be opposite to that generalized coordinate, what we have assumed. So this is all about the Lagrange's equation. In the same way, we can calculate the rest problem. So if you want, then we can take one more example to solve. Then I can take one more example, and with that example, I can show you how we can get the answer. Most of the time, this concept is useful to get the equation of motion. I know that you have studied the concept of vibration. So in the concept of vibration, this Lagrange's equation is very useful, because in that, if you know that how we can apply this Lagrange equation, then by using this equation you can easily calculate the equation of motion. Fine. So please please give the suggestion in comment box. If you want to solve one more problem, then I can solve here. Otherwise, this is all about the session, and we can complete the session here. Okay, so when I saying, sir, one more example. Okay, so right now I'm taking one more example. Fine. So let us assume right now we are taking one example of a string mass system. So why I taken this example? Because the same concept you use in theory of machine, vibration subject. So how we can develop the equation of motion here? So that I am going to explain here. So this is time. Can anybody tell me what is the degree of freedom of this system? Can anybody tell me what is the degree of freedom of this system? Because this question I want to solve with the help of you. So you tell me, then I will solve this question. Okay. So the degree of freedom is 1. Either it will be the linear displacement or angular displacement. Just please response in hurry. So exactly. So Nihant is saying, Vinay is saying, Muhammad Zahid is saying degree of freedom is 1. Exactly. That is correct. So just tell me that degree of freedom, that coordinate is linear or rotational. Very good, Vinay. Very good, Nihant. So that coordinate is nothing but it is linear. So we are considering in this direction positive. So let us assume that the generalized coordinate is capital X. That means we have defined Q is equal to X. And because the system have only 1 degree of freedom, that means we have only one generalized coordinate. One note is stopped working. Please give me 1 minute. Okay. Okay, so I hope it is visible to you. So in this condition, because the system have 1 degree of freedom, that means the generalized coordinate will be equal to 1, and we are assuming that generalized coordinate is linear displacement that is equal to x. Fine. So in this condition, we are, because this in the theory of machine we assume that spring is massless. So there will be spring is massless, so there will not be